Thanks for the invitation to speak. It's a pleasure to be here to speak to you. I think in the prospectus it was indicated or implied that I'd be just talking about marine warranty surveying, but I've tried to bring in some aspects where I see the wider marine assurance aspects of offshore wind into the presentation, with some sort of reference to eCMID and where I see that in the process, as it has begun to be used pretty much as the standard in the European offshore wind market. But I see some challenges in rolling that out here in Asia, unlike in Europe. So, in terms of the presentation content, I'm going to talk about why we're talking about wind, other than a hot beef rendang last night. I'm going to propose the question, do we need marine warranty and marine assurance for offshore wind projects? I think you probably already know what my view will be on that. I'll talk briefly about MWS scope, the contracting process for offshore wind. Talk a little bit, as I say, about the wider marine assurance aspects for offshore wind, and then look at some of what I think the Asian market challenges are. So why are we talking about wind? I've put a quote here. This was more for a marine warranty audience, but this was a quote from a locally based underwriter that's in the construction full risks community for offshore wind or for energy. Their view was, oh, it's well too early. You know, it's not happening here yet. Why are we worried about it? I think he needs to inform himself a little better. The offshore wind growth, as we know, is massive at the moment. This data was from 2017. There isn't a 2018 report yet that I can refer to. So, but the overall, it's looking in the next 10 years at something like 85 gigawatts of offshore renewable energy will be installed, and average capex about $3 billion per gigawatt. So $250 billion worth of investment in the next 10 years within the sector as a whole globally. And the important thing is that although historically we've been used to Europe being the focal point, what we can see is that the whole of the globe is now taking this on board in the shift to renewable energies. And really importantly for us in this region, Asia is coming to the fore. I haven't indicated all the locations that Asia, because Vietnam's missing off here, which may become a bigger market. Even Malaysia's talking about it. Australia's just approved an offshore wind farm off Melbourne, despite the massive land masses that they've got there that they could put them onshore. They've decided to put them offshore anyway. But there are 4 key markets that are going to drive growth in this region initially, and that's South Korea, Japan, Taiwan, and China. To give an indication of where they're going to sit, in 2016, China and Japan were already on the list. But if we look going towards 2024, although Japan's moved down the list, if we look at the massive increase in power wattage that we're looking at, and China has moved to the top of the list as the biggest market, Taiwan joins the fray in the top 10, and in fact South Korea comes in at number 11, and the massive jump in terms of the gigawattage size is between the two. 8 times growth for China. So the new installed capacity in Asia over the next 5 to 6 years is about 17 gigawatts, and so that's about $50 billion worth spent. So it's significant. So that's why we're talking about it. It's going to be a growth market in this region. But do we need MWS and marine assurance for offshore wind? Well, at the start, it was perhaps debatable. This was your sort of early doors type of offshore wind project. It was 1 or 2 turbines in estuarial, very tidal, get to it from the beach at low tide to do the work. So there was very little focus on the marine aspect. But the trends are that we're getting bigger and we're getting deeper. So this graph shows all of the wind farms currently in operation, under construction, and approved for future. And what we can see is the trend is moving to the right of the graph. So we're getting deeper and deeper water, and we're getting further and further offshore. And the average size in terms of number of turbines that we're looking at within each development is growing as well. What we're also seeing is that the turbine sizes themselves, in terms of their output as an individual unit, is growing. So in the early phases, we were looking at monopile 2 to 3 megawatt. This is, when I say early phase, this is only 2012. And by 2020, we're already now seeing new 7 megawatt units coming out. And we're probably going to 8 or 10 megawatt units, and we're going floating as well. Why is that? Well, the economics drive us that way, in that the bigger units are more efficient, and for a cost per unit in terms of what the output's going to be over the life cycle, we see some cost improvements. So the trend will continue that way. We're also seeing that the type and complexity of the structures that we're looking at are changing. As I said before, the early stages, simple monopile type structure in very shallow water, but what we're now seeing is a whole myriad of types of structures, some of which we'll start to see. This isn't looking like offshore wind, this is looking like oil and gas. So we've got gravity-based units, we've got suction pile monopods, we've got jackets on traditional driven piles and also on suction piles, the deeper we go. And we're also going floating as well. There's often a debate, it's surely we don't need to be going so far offshore that we need to be going floating, but this is all about whether we've got enough space to put the size of offshore wind farms that we want, and that we can accommodate the bigger gigawatt units on a traditional foundation type structure in certain parts of the world. And obviously these new units bring in a whole range of new aspects that are all marine driven: stability, the wet towing of these units, the mooring, both during fabrication and then transportation and site mooring, the hookup and cable risers and pull-in. We're having to bring things up to non-fixed structures that are dynamic. We've got the whole issue of risers and transmitting the cable. And these are happening. We've already had 3 major projects that have gone through initial concept phases and have gone out for trial units: wind float in Portugal, high wind in Norway, float gen in France. Now, some of these points may all seem, well, this is all European centric, while we're worried about it here in Asia. Well, the reality is that it's unlikely that Asia is going to go back to the start and go through all of the development, understanding and life cycle that we have in Europe. We're likely to go straight in at the later phases because it's more economically viable. And the component sizes themselves are getting huge. If we look at 7 megawatt Siemens turbine, one of the more recent ones, I don't know if you're familiar with the Gherkin in London, which is 180 metres tall. The latest Siemens is 190 metres tall, so it's taller than the Swiss Re Tower, the Gherkin in London. To give you an idea what that means here in Singapore, it's the same height as the Marina Bay Sands Hotel. So huge, huge structures we're talking about now, and the logistics and the marine operations in terms of loading them out, transporting them, lifting them, are becoming major enterprises in their own right. The substations, so they've got the turbines, but you've got to get the power ashore, so you need substations to do that. And in the early days, we were looking at small structures like this with the 300-ton topsides, but as the fields are getting bigger and the wattages are getting larger, we're getting up to, you can't quite see it under there, but 10,000 tons in weight. So we're really talking big big structures, and even semi-subs. So again, this is all historical stuff that is happening right now in the European market, and I think what we'll see is we won't go back to this. We may for some of the demonstrator jobs, but when we start getting into the bigger fields, we may be moving this way quicker than we think here in Asia. So, as I was saying, the operations that we're looking at are way more akin to the oil and gas environment than perhaps we might have thought. And we're actually using, I mean, obviously some of you recognise this as one of the Herema boats. I'm not sure if it's the TF or the Hermod, but so we're utilising the same assets as well. Cable lay operations, similarly, this is how we started out. And this is where we've got to now with highly sophisticated big carousel cable lay vessels. And as a result, we've got more specialised vessels. No longer are we using a crawler crane on the back of the barge. We've now got very distinct purpose-built units that we're using in the European market. And I stress that because we're not there yet here in Asia. And it may be some time until we get there. And with these higher, bigger units, longer duration marine operations, higher value assets, although the risk of failure is lower because we're further down the track, the consequential loss values that we're talking about from an insurance claim aspect or from delay to startup increases because we're going deeper, we're bringing in new aspects. And unfortunately, bad stuff still happens. So that means, as far as I'm concerned, that we've got a growing market, we've got a growing asset value and growing complexity, increased capital investment, increased risk, increased need for insurance provisions, increased potential large claims. So that definitely brings in the reason why we're seeing an increased need for marine warranty survey within the offshore renewables sector. And similarly, on the marine assurance side, by virtue of the increased amount of activity, we've got more marine operations, we've got increased complexity, we've got more turbine operation from a maintenance and overhaul perspective, we've got increased capital exposure and increased vessels working within that space. So by virtue of that, we're going to need an increase in marine assurance. So it is a growth market as globally and here in Asia. So from an MWS perspective, what is our normal scope? How are we contracted and what sort of process do we follow? In the same way as the oil and gas environment, the extent of this scope would be negotiated between the insurer and the assured via their broker. The insurer's requirements for the warranty scope will be based on the following: the level of internal assurance measures already in place, the complexity, novelty or sensitivity of the proposed operations, the asset value, weight, size or project schedule criticality of those assets. The assured's previous insurance claims history is quite a big driver to it. And the underwriter's claims history through other clients on similar projects. Thereafter, it's for the assured in consultation with the marine warranty surveyor normally to add their own assurance requirements on top of that to generate the final scope. What is the generic scope? Validation of project conceptual design at the front end, review and approval of marine operations procedures and associated engineering based on agreed criteria and specifications, attendance at marine-related hazards or HAZOPs and procedures reviews, inspection and audit of the marine transportation and installation fleet, and attendance on site to witness and approve the defined marine operations as required. And traditionally, so far, what we're finding is this is focusing on the major assets within the development. So we've got our turbines, we've got our substations, we've got our cabling. For this, and then we've got the yard handling and road transport of the equipment to the quay, the load out and sea fastening of the components on the transport vessels, the transshipment to the installation vessel, and the offshore installation lifts or other offshore installation activities. For the substations, we've got traditional trailered, lifted or skidded loadouts depending on the weight. We've got the sea fastening transportation of those, and then the offshore heavy lift for install, or possibly float overs, as we're now starting to see. So again, even more marine interaction there. And on the floating units, we've got dry dock, undocking, construction of float, wet tow or dry transport on an HLV, mooring, hookup and ballasting, and then the cable and riser pulling. So the marine warranty surveyor will be looking at all of these critical operations, reviewing the engineering and procedures, making comments on those for improvement, and then providing an approval of that documentation, and then attending on site to oversee the preparation for those activities. Cable and spooling as well. We're seeing that cables are probably the biggest source of claim in the whole of the offshore environment, in the offshore wind environment. Quite often it's failures post the actual physical installation during operation, and it's not clear yet whether it is fundamental quality levels within the production or whether it's failures due to damages occurred during installation. But just purely due to the sheer number of cables that you might be looking at, if you've got 100 turbines, you've got 100 interconnecting cables. If you've got 300 turbines, it's 300. So compared to a normal oil and gas type of project where you may have 3 or 4 umbilicals, you've got a huge multiplier in terms of the chance of a failure within those units. I often hear underwriters saying, oh, but the claims ratios on offshore wind projects are so much higher. I said, no, they're not. You'd need to have 30 times more oil and gas projects to have the same number of umbilicals laid, and therefore actually, you show me probably is 1 in 30 is the failure rate on an umbilical damage. Cable crossings, post-lay burying and trenching is another big area for potential damages, as it is for traditional cables. But we have to be aware that because there are so many assets, that the cost of surveying every single unit is probably impractical compared to the value of the unit itself. So we often see a first of type approach or a percentage approach. So if there was 100 cables, we might be asked to look at 10%. So we look at 10 of those 100 at phases during the installation and make sure the contractor was keeping up with the same level of quality of their work. In terms of the contractual and operational relations, this is a standard contractual organisation in any offshore construction project where you've got the developer who is looking to seek to take out their insurance. They're going to take out construction risk policy via their broker to the underwriter. There may be some joint rig committee kind of scopes thrown into that policy. And then the MWS would work for the developer and review the contractor and the vessel operator's work. There are alternative contracting strategies, and particularly here in Asia, we're seeing it more common than in Europe, certainly, for the marine warranty surveyor to actually be contracted directly to the underwriter, mainly because of the lack of understanding of the need or the benefit or the role of the warranty surveyor by some of the developers or operators. And therefore, at the moment, until that learning comes, it's easier for the underwriter to make sure the work's getting done if he's contracting as direct. But we can also obviously be to the contractor because the developer doesn't want to manage our work either. And then from an operational perspective, as I say, normally bolted straight on, liaising directly with the developer with a communications link to the contractor because it's his work that we are effectively reviewing. But it's essential that there's still the ability to communicate back to the underwriter for the warranty surveyor to feedback the quality of the work. And then from a process in an ideal world, we have a two-phase piece of work where we start with the desktop review, setting the design basis and criteria, then doing the engineering review. We would then issue a warranty review letter from the individual procedure or engineering document. If it's up to scratch, it would be approved, we move on. If it's not, feedback comments would come back to the contractor to up-rev the procedure and improve it until it's approved. Then we move on to the attendance work. What increasingly happens is that the schedules get squeezed so much that this work's going on in parallel and often overlaps, which isn't ideal in terms of making sure that we've got this all nailed down before we move on. We then do the suitability surveys of the vessels and equipment. We attend on site to look at the operational preparation. And if that's all okay and the weather's looking good for performing the operation within limits, we issue certificate approval. And then we would stay on site and we would oversee and witness the operation to make sure it's then done in accordance with the procedure. So obviously there is already marine warranty within the offshore wind space. We are already working as warranty surveyors in Asia for offshore wind, as well as in Europe, which is a much bigger market. But what about the wider marine assurance piece? Is there a need for marine assurance on top of the MWS side? My view is definitely yes. So why is that? Well, from a MWS suitability survey perspective, we're actually looking at quite a ring-fenced view in terms of what we're looking at when we do a suitability survey audit from a warranty perspective. Is it suitably equipped for the task? Is it good operational condition? Is it required statutory certification? Vessel is adequately manned and managed, vessel specifications and capacity have been accurately presented. Ultimately, all we're doing is we wanted to make sure that when the operator has said to the underwriter that they're going to be using vessels like that, they're not really using vessels like this. And we are not going to go into as much depth as you would do in a full eCMID or a more granular audit. And so I think that for the ongoing activities, and particularly for the operational phases of the maintenance, you're not going to have a warranty surveyor there because he's only there in the construction phases. And so for non-marine warranty assurance, where are the drivers for where the requirements for this are going to come from? Traditionally, they're going to come from the developer. Have they got corporate requirements that are driving them to maintain a minimum standard? We've already said that Dong or Ørsted and Siemens have already dictated that they're going to be using and only using ABI surveyors. Or is there a regulator, a local marine body, a power regulator, a government entity that's requiring a minimum standard to operate in their area of operations? From that, we get contract flow down to the contractor to say, right, okay, these are our requirements, Mr. Contractor, you need to comply under the contract. But the contractor themselves may also have those corporate requirements. It may be a recognised marine operations contractor that's used to working in that space and wants to maintain that level. And then they will obviously engage a surveyor to undertake the survey. We may have a separate vessel operator, and they will obviously be contractor to contractor, and it will flow down from them, and they may also have their corporate requirements. So this all sounds good. There seems to be plenty of ways why we may see the need for marine assurance. And we have the tool. We've got eCMID and the eCMID system, commonly used and established in the European offshore wind market, and it's the most suitable tool available for the job, in my view. But if we go back to this screen, let's look at where these input requirements are going to come from. Regulator requirements, if there is one. Offshore wind often falls out local government or industry regulations, particularly in this neck of the woods. They're not there yet. Their mindset isn't there as to, for them, it's just an extension of onshore electricity power, and those regulators don't have any real understanding of the marine environment. Corporate requirements for the developers. Yes, if it's an international oil company or energy company, globally established renewable company, but unlikely if it's a local energy power company, electricity company, because they don't know what they don't know. From the contractor, yes, again, if it's an established contractor used to working in regulated industry, but unlikely for Asian marine civil contractors. So of those big Asian markets that I said before, Taiwan has definitely taken a view that they're looking to bring in knowledge-based learning from the European market, and they're being very open to access from some of the big European contractors to work within their environment. The same can't be said of Japan, Korea, China particularly, where they're very much pushing to try and generate their own market, create new contractors, or move existing marine civil contractors into that space, but they haven't been working in those traditionally regulated environments. And the same can be said for the vessel operator, who probably isn't an IMCA member, which is a big challenge, and is a local tug or barge operator, or he's just not used to, he's used to just trawling stuff up and down his coastline. He's not used to having a whole bunch of surveyors come on board, or he won't have any corporate regulations pushing him to do this. And the other one is the surveyor. Have we got sufficient local qualified surveyors to actually go down this route anyway? We've got a lot of offshore related surveyors, but not in certain jurisdictions that we're looking at for some of this work, because some of them traditionally haven't been big oil and gas centres. Taiwan certainly isn't, Japan certainly isn't, Korea certainly isn't. They might build stuff for the oil and gas environment, but they're not operating offshore and actually doing it themselves. So I think there's a few challenges that we're going to have if we want to grow this. It needs it. It's going to be a growing market. And what are the big challenges on top of that? I think the lessons learned, being able to bring what we've learned in Europe to Asia is the biggest challenge. Otherwise, we're going to be reinventing the wheel. Knowledge transfer is going to be key, and finding ways to do this. These are just some of the questions, even in the European market, for new power, energy, offshore wind related companies that we regularly hear. And again, it's about their lack of understanding of the need for it, why the underwriters even ask for it, and what we do. This lack of knowledge is coming from lack of regulation requiring that minimum standard. Local Asia power companies not used to operating in the marine environment. Local Asian contractors not used to working in offshore projects, or in some cases even offshore. Local Asian vessel operators not used to working to international standards or with third-party surveyors. And as I said, limited IMCA membership from the local Asian contracting market. So for the time being, the education of that market is down to you guys. It's down to us. We've got to find ways of engaging with them and making them aware of the benefits that this is going to give them. Not easy. The next bit is the contractual equipment standards. We've seen continual improvement over a decade of the types of vessels we're using. But every time we enter a new market, we're back to basics every time. We're back to the same old, well, we can just use a barge and stick a crawler crane on the back of it. We don't need the fancy big jack-up vessel to do this work. So the standards always go back to square one, and you're reinventing the wheel. So we've got to push through this quickly and get to the other side and get them using those more reliable assets. I think there's some new technical challenges. I mean, jack-up drilling isn't a new thing in Asia by any shape or form, but jack-up operations in the sort of locations that we're going to be installing these offshore wind farms is, and some of the contractors that are going to be moving into this space and suddenly thinking they're a jack-up operator is going to be a challenge. And I think that, again, an educational piece and a requirement for making sure that standards are maintained from a marine assurance auditing perspective in those operators is essential if we're not going to have a spate of jack-up related issues. The next one. Well, normally we've got a wind farm, we want wind. Wind means money. But in the Asian market, what about too much wind? We don't have typhoons in Europe or many other places around the world where we've got offshore wind farms. Now, obviously, the designs of these new units are going to be, for their in-place case, is definitely going to have to contemplate it. But we've got installation phases where they're not fully installed. And I think we're going to see a spate of contractors that, although claim to be marine contractors, aren't used to looking at weather windows, the length of operation, and what that means in terms of exposures from a typhoon perspective. And I think there's going to be some challenges in getting people to understand that their installation schedule windows are going to have to be much longer than they're currently budgeting for, because there is going to be weather operational delay in waiting for these events. And the biggest issue faced for you guys out there, and for the warranty surveyor as well, is the classic late engagement. This is, I don't know how many times I've heard this one. Oh, hello, yes, I wonder whether you can help me. We need to organise a marine warranty surveyor for our project. Our first operation, yes, that's tomorrow. Do you have anyone available to attend? The causes, again, a huge lack of marine interface experience on these projects, particularly in the offshore wind environment. We've got logistics coordinators, we've got guys that are used to, or contracts engineers that are used to working in the onshore space. They've got no idea of the lead time on some of this work. So we need to get in there and educate them at the ground level. Late placing of the insurance or definition of the scope, accelerated project schedules, lack of understanding of the survey requirements and how long it takes. And I want to minimise external surveyor involvement or impact as they see it. And the effects, well, obviously it means we're all rushed in doing our work. You're not going to get as good quality outcomes. We see a lot of the main equipment and contractor contracts being placed ahead of the warranty and surveyor or surveyors being involved, and therefore the incorrect equipment is being contracted, and it's hard to retrench from that position. Inappropriate design criteria is being set early, and limited time for the technical review or the audits of the vessels prior to operation. And what does that lead? Well, it leads to all of us becoming rather frustrated. So, summing up, I think the offshore wind farm market in Asia is going to grow rapidly, and we have to be on board with that and on the back of it. The size, complexity and value of the structures and operations we're going to be looking at, I think, will accelerate quickly. I don't think we're going to go back to the early days of the European market. We're going to go straight into a more advanced market. There's therefore an obvious need for marine warranty and marine assurance provisions within the market. The MWS processes and scopes are very akin to that provided in the oil and gas industry. However, there's far less understanding within the renewables industry of what that process and requirements are. It's expected that eCMID will become the primary marine assurance vehicle, but only if the Asian market is educated into its benefits. I think we will get there eventually, but we could get there quicker. I think attracting the Asian contractor market, becoming the members, an essential part of this, and engagement with the national independent power companies and regulators is needed to grow the marine assurance market. Let's make them see that there will always be a tendency to think that they can do it themselves, and they'll only come back to us, as you quite rightly said before, when there's an incident and somebody loses money out of their pocket and they think, what could we have done differently? And we need to educate them that we can save them time, we can save them money at the front end. They don't have to go through that learning cycle. We've also got some specific new technical challenges in the face of new development areas due to geography, as I've mentioned. And I think that we all have an obligation to try and start this new market on a high base rather than a low one. Thank you very much.
Alex, thank you. Thank you for an insightful presentation and fascinating. Anyone got any questions? He's running away, but has anyone got any questions?
Run away quick before they ask him.
Just wait for the microphone, Joe, please.
Yeah, you looked at the wind and typhoon factor, but this is what about seismic activity around this, especially when you showed that curve there. Yeah, you put in massive, big numbers of installations down. I presume they're bound to be looking at this. And what are the possible down effects? I mean, are they going to dig deeper, or what's the solution to that?
The solution to it will be very much dependent on. There's also tsunami that comes with seismic events as well. It's very much going to depend on the foundations or the soils that they're installing on as to what's needed to do to compensate for it. Obviously, they are having to look at it from an in-place design case. I was looking more in that slide in terms of the impact on the marine operations for actually installing them in the first place and the considerations for that. There is obviously in-place design considerations. Japan is clearly looking at going more floating than they are fixed structures for that very reason. I guess I know that the insurers are definitely looking at it, and the BSMI, who is the sort of standards institute that set the minimum design requirements in Taiwan, have certainly started doing some development focus on seismic activity. So it is being considered.
When you're doing a float over and with very tight margins to do that, then I mean, we don't get forecasts of these things. They just generally just happen. I mean, the potential for something to go very badly wrong if the seismic activity.
Yeah, I think if you looked at the loss frequency ratio of the likelihood of having a seismic event at exactly the time that you were setting one of these down would be so low that probably the money men aren't going to worry too much about it. But I agree that there is the potential.
Further questions? No?
Right.
All peace and quiet. Lovely, thank you very much,
Everyone's
Alex.
too keen for their lunch.
Everyone's too keen for their lunch. Right.